Welcome back, guys. Let's go ahead and jump into this problem set. All right, so number one said to create a model to represent the following percents. So really they were just looking for you to draw basically some sort of grid like this, or like a bar or something. So what they've done is they've drawn 100 boxes and colored in 90 of them. That's totally fine. You could have done like say like a bar. So take one of these rows, like take this row here. So if that was all you had were the 10 rows, you instead would have only colored in 9, right? And that still would have been 90% of the 10. So I'm just looking for, this was the most basic answer, but if you drew something else, as long as 90% of them were colored in, you got it right. Okay, 0.9%. Like we said before with the definition of percent, we take whatever our percent is and we take that out of 100. So this one would be 0.9 out of 100, okay? So they have 100 boxes here. So if we want 0.9 of them, well, we just color in 9/10 of one box, okay? So still not at quite 1 here, so there shouldn't be a whole box filled in. Let's see if we can zoom in on this guy. There we go. Okay, so we have 100 boxes, and our percentage is not quite at 1%, so we shouldn't have a full box filled in, and we don't, which is good. So for a minute, let's forget about the rest of them. Let's just look at the one box that is partially filled in, okay? Think to yourselves, if that was the only thing we had, and this was colored in, which of these other problems would that be equal to? Part C, 900%. Okay. First thing that you should notice right off the bat is that this is greater than 100%, so we should have at least an entire grid. So whatever we're considering our whole to be, in these problems it's been 100. We need more than that. So if we take 900 out of 100, and then we reduce that fraction down, it just reduces down to 9. So we should have 9 wholes. Okay, and since for this problem we're considering a grid of 100 boxes to be one whole, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and part D, again, so this one is 9/10%. So if you want to just go ahead and convert that fraction to a decimal, that's 0.9. Yeah, that is exactly like part B, so we're just going to call that good. Okay, for number 2, we need to figure out if Benjamin is correct. So he says that 0.5% is the same thing as 50%. What do we think? Is he correct? Is he incorrect? Let's work through the math to find out. Our definition of percent was that P% is the same thing as P out of 100. Okay, so we have the following. We have 0.5% and we have 50%. Well, hopefully you guys can tell that right off the bat, 50 and 1/2 are sort of not the same thing, right? 50 is a whole number. 1/2 is a fraction. 50 is more than 1. 1/2 is less than 1. So I'm predicting that these things are not going to be the same thing. But let's go ahead and work through it and make sure. All right, so 0.5% is the same thing as 1/2 out of 100. 50% is the same thing as 50 out of 100. All right, and now let's get these fractions. So we've got a complex fraction and a regular fraction. Well, neither of them are reduced. So let's go ahead and turn this complex fraction into a regular fraction. And we're going to do that by multiplying by 10. Because 10 times 1/2 is going to give us a nice whole number. We could also multiply by, you know what? For this 1/2%, well, usually we multiply by 10. What I'm going to do is I'm going to multiply by 2, just to show you that that's another way we can do this, okay? So 2 is the denominator in the numerator. I know it sounds kind of weird, but in complex fraction, we just got to get used to that stuff. So we're going to multiply the whole thing, so top and bottom, by the denominator of the numerator, okay? So we're going to multiply the whole numerator by 2 and the denominator by 2, okay? 2 times 1/2 is just going to give us 1, and 100 times 2 is going to give us 200, okay? Now let's go ahead and get this one reduced as much as possible. Well, let's see, first of all, they are both divisible by 10. So we can cross out a 0 from each one. So that's 5 out of 10. They both have a factor of 5, so we can divide top and bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And so we have 1 over 200 and 1/2. Those are very clearly not the same thing, so Benjamin was incorrect. Number 3 says to order the following from least to greatest, okay? So what it does is it gives us a bunch of different, we have percents, we have fractions, we have decimals, and while they're all sort of in those sort of random forms, it is harder to be able to tell, well, hey, well, this one's greater than this, and so on. So the main thing to do in a situation like this is to convert all of those numbers into the same form. So like either all percentages or all decimals or all fractions, okay? We are going to put them all in decimal form, and this might be a little out of character for me. You guys know that I hate decimals, but we are going to go ahead and convert all of these to decimals. So the first one is 100%. And hopefully that's easy enough for you guys. 100% is just 100 out of 100, and so we just have 1. 1.0. Okay, the next one, we have 1 over 100. 1 over 100. Okay, so we don't have to go, we can just go right to decimal from here. So remember, we're dividing by 100, so the decimal is going to go to the left 2 decimal places. There's 2 zeros, so 2 decimal places. So if we have our decimals here, we're going to go 1, 2, and put it there. And so we have 0.01. Okay? So right off the bat, okay. So the next one we have is 0.001%. 0.001%. Okay? We have a percent. So that means we need to take 0.001 out of 100. All right? Now, again, we're dividing by 100, so the decimal point is going to go to the left 2. So it's here, it's going to go 1, 2. So we're going to end up with 0.00001. Really small number. Next, we have 1/10. 1/10. Okay, we're dividing by power of 10, so the decimal is going to move to the left. We only have 1 0 this time, so it's only going to move 1 spot. 0.1, or 1/10. Another kind of easy one. Okay, next we have 0.001. So it's already in its decimal form, so that's great. 0.001, 0.001. Didn't really have to do anything to that guy. We're not going to have to do anything to the next two either because they're already in decimal form, which is great for us. So the next one is 1.1, which is just 1.1. Finally, we have 10. We could say 10.0 if we want. All right. The last one is 10,000 over 100, out of 100. So that's 10,000%. All right. Well, to turn it into a decimal, we're dividing by 100. So we move the decimal to the left, 1, 2 spaces. So if the decimal's here, it's going to go 1, 2. So it's right there. So we have, okay, which is just 100. Great. Okay, so from least to greatest, so number 1 is going to be 0.001%. 0.001%. All right, and I'm just going with the original numbers that they gave us. So I'm using the decimals that we converted to decide what's bigger, but when I write it here, I'm going to actually write the number that they provided, okay? Followed by 0.001. All right, next we have 1 over 100, because it was 0.01. Next we had 1/10, which was 0.1. Next one was 100%, which is just 1. Followed by 1.1, I believe. Yep, 1.1. And then 10. And we're going to finish it off with 10,000 over 100, which was the same thing as 100. All right, so here is your list of numbers in the proper order from least to greatest. Okay, number 4 I think was pretty self-explanatory. You know, we did a couple exercises like this in the examples, and so I'm just going to put the answers up here so that you guys can check your work. And if you didn't get the right answers, that's okay. Just go back, try again, see if you can figure out what you did wrong, and see if your new answer aligns with the correct one.